What is a piecewise function? If I were to start from an intuitive approach to understand piecewise functions, let's start by considering the two lines y equal to half x minus 1 and y equal to 3x minus 6 graphed on the given coordinate system. Suppose I remove part of the line y equals to half x minus 1 and do the same for y equals to 3x minus 6, making sure that the remaining parts form a function that passes the vertical line test. Now, in this case, I end up with a function defined by parts of two different functions, one for x greater than 2 and one for x smaller than 2. Now, that is a piecewise function. And piecewise functions could be formed by parts of more than two functions. For example, this function is formed by parts of three different functions. And at the points connecting different parts, the function could be continuous or it could be discontinuous. Now, how do I graph piecewise functions? If I'm given this piecewise function defined by 2x plus 1 when x is smaller than negative 1, and by x squared when x is greater than negative 1, and I wish to graph it, I need to first start by pointing out for which value of x the function changes expression. In our case, it's for x equals to negative 1. Now, when x is smaller than negative 1, and that is on the coordinate system, the region to the left of x equals to negative 1, our function is defined by y equals to 2x plus 1. However, I start by graphing that function over all r and then remove the part of that curve that falls outside our given region. And then, at the point of abscissa negative 1, I look at the inequality. Since x is smaller than negative 1 here, strictly smaller than negative 1, in that case, the point of abscissa negative 1 on that part of the curve is restricted. So graphically, it is represented by a hollow point because it is not part of our curve. Now moving to the other part of the function defined when x is greater than negative 1. Now x is greater than negative 1 to the right side of x equals to negative 1. Now again, over this region, the function is defined by y equals to x squared, which I also start by graphing over r, and then remove the part of the curve that falls outside of the region corresponding to x greater than negative 1. And again, in order to determine the nature of the point at x equals to negative 1, I look at the given inequality. Now, the given inequality is x greater or equal to negative 1. And the fact that I have an equal there means that the point of abscissa negative 1 is part of the curve. It is not restricted. Consequently, it is represented by a full point. And that is finally the curve corresponding to the given piecewise function.